There is something deeply unsettling hiding inside the most successful scientific theory ever created. Not a gap in the knowledge, not an unanswered question waiting for more data. Something stranger than that. A discovery so fundamental, so radical in its implications, that even the physicists who work with it every day disagree about what it actually means. And yet, it has been tested, verified, and confirmed with a precision that no other theory in the history of science has ever matched. It is called quantum mechanics. And what it reveals about the nature of reality will change the way you see everything. Because for most of human history, the assumption was simple. The world exists. It is out there, solid and independent, whether or not anyone is looking at it. A tree falling in a forest makes a sound even if no one is there to hear it. The moon is in the sky even when no one is watching. Reality, in this view, is something fixed, something external, something that simply is, regardless of observation, regardless of experience, regardless of you. But quantum mechanics says something different. At the most fundamental level of reality, the level of atoms, electrons, and photons, things do not behave the way you would expect. They do not exist in fixed positions until they are measured. They exist in a state of pure possibility, a superposition of all the places they could be, all the states they could have, all the directions they could be moving. And the moment you measure them, the moment observation occurs, that cloud of possibility collapses into a single outcome. Not before, only when observed. This is not a limitation of our instruments. It is not that the particle was always in one place and we simply did not know which. The mathematics, confirmed by decades of experiments, tells us something far more radical. The particle genuinely did not have a definite position before it was measured. The act of observation is not just revealing what was already there, it is participating in the creation of what appears. And if that is true, then what exactly is reality made of when no one is looking? This question was at the heart of one of the most famous experiments in the history of science, the double-slit experiment. In its simplest form, a beam of particles, electrons, photons, even atoms, is fired toward a barrier with two narrow openings. On the other side, a detector screen records where the particles land. If particles were simple objects, like tiny bullets, you would expect two clusters to appear on the screen, one behind each slit. But that is not what happens. When no one measures which slit each particle passes through, the particles behave like waves. They spread out, pass through both slits simultaneously, and create an interference pattern on the screen, the overlapping ripples of two waves meeting each other. The particle, somehow, passes through both openings at once. It exists in multiple places simultaneously. It is not here or there. It is everywhere it could be, all at once. But here is where it becomes deeply strange. The moment you place a detector at one of the slits to measure which path the particle actually takes, the interference pattern disappears. The particle stops behaving like a wave. It chooses one path, becomes a definite thing, and lands in one of two clusters on the screen, exactly as you would expect from a simple object. The act of measurement changes the behavior of reality. Not because the detector disturbs the particle physically. Physicists have designed experiments specifically to rule that out. The change happens because information is obtained, because the which path becomes known. And somehow, at this fundamental level, what is known and what is real are not as separate as they seem. This is what Einstein could not accept. He spent decades arguing that quantum mechanics had to be incomplete, that there had to be hidden variables beneath the uncertainty, that God does not play dice with the universe. But experiment after experiment, including the landmark tests of Bell's theorem in the 1980s, confirmed what Einstein refused to believe. The universe, at its most fundamental level, is genuinely indeterminate. Not just unknown, but undecided until the moment of observation. And this opens something extraordinary. Because if reality at its most fundamental level is not fixed, not independent, not simply out there waiting to be discovered, then what is it? Some physicists have proposed that what we call reality is better understood as information. Not matter, not energy in the classical sense, but patterns of relationship, structures of possibility that become definite only in the context of interaction. Others have gone further, suggesting that consciousness itself may play a role that physics has not yet fully understood, that the observer cannot be cleanly separated from the observed, that the boundary between the one who looks and the thing being looked at may be far less solid than it appears. These are not fringe ideas. They are the honest conclusions of serious physicists sitting with what the mathematics actually implies. And when you place them alongside what we explored in the previous videos, the constructed nature of the self, the appearance of time within awareness, the possibility that consciousness is not produced by the brain, but is the very ground in which experience arises, something begins to emerge. A picture of reality that is not mechanical, not cold, not indifferent. A universe that is, in some deep and still poorly understood way, participatory. A reality that does not simply exist, but that appears within something, within awareness. And if that is even partially true, then the universe you think you live inside may be far stranger, far more intimate, and far more connected to what you are than anything you were ever taught to believe. So the next time you look at the world around you, at the solid objects, the fixed distances, the seemingly independent things, remember what is hiding beneath all of it. Not matter, not certainty, but possibility, waiting to be observed. And in the next video, we will go even deeper into what the universe looked like before any of this existed, and what the very beginning of time and space reveals about the nature of everything that came after.